So thrilled to have Matt from Denver. As I've mentioned earlier, it's always great to have out-of-town guests and who have different perspectives. So Matt's part of the CSIRT team for Dell EMC, and I would like everyone to give him a very warm Calgary welcome. Thanks, Matt.
Thank you, guys. Thank you very much for having me. We'll go ahead and get started. I want to get through some stuff because we do have a lot of content here. First and foremost, who am I? So I got into security, very long, circuitous, accidental route. I started off at the United States Air Force Academy. My goal was to fly fighter planes because it was going to be fun. It turns out I'm the worst pilot in the world. And so they said, you really need to go do something else, anything else. So I finished out as an electrical engineer. I went and I started working for the incumbent in the SpaceX race. So we know who SpaceX is. The incumbent in that one, the one that charged a ridiculous amount of money for every launch we did, I worked for them. And I did embedded hardware for, so essentially I did TCP/IP stack for embedded systems for their guidance boxes. So then RSA came and went, hey, if you know networking, come on board, we'll teach you security. So I've been doing this about 4 years, and in that time, I'm now Grifter's compatriot. So currently there are 2 of us. We're hiring a bunch more to do the same kind of thing we do, but we are full-time hunters. It's unusual to see in these environments. In fact, we went to a SANS threat hunting summit, and there were like 300 people in the room, and they went, and how many of you actually get to hunt as your job? And like, Grifter and I were the only 2 going, oh, look at that, maybe it's just us. And so when we would go on engagements, we needed a process that we could work through such that we had coverage of everything, and we weren't stepping on each other. And so that's how we came up with the labyrinth. And we named it the labyrinth because there are so many other things out there, the kill chain, and the diamond model, the hunting maturity model, and we felt left out. So we named it the labyrinth, and we'll talk to that here shortly. We're going to start with what is hunting, and we're going to slowly dig down, sort of frame up our mind on what it is we're talking about. So very first, hunting. We know that our preventative controls aren't working. I mean, we know that, right? So the idea is we assume we're already compromised, and we start looking for indicators of that. We enjoy looking for these things because it's much harder to hide with somebody looking for you. It is not responding to alerts. In our EMC Dell CSIRT, when we are looking at alerts, we even consider that to be IOC hits from threat intel. So threat intel hits, we still don't consider that hunting, okay? That's our alert queue. The reason we like this is because you really get to understand your environment. You get to know who your threat actors are. We have on the order of 60 that we track. That we know have actively targeted us previously. So we get to understand that concept and the indicators associated with each one. Also, you really get to understand your endpoints, what's normal in your environment. Do you use Skype? Because that looks weird, right? And so we play those kind of games. Also, network. We talk about network protocols, we talk about what they look like, and then when we actually get in and use them, you see that the internet is a very broken place, right? And so we'll talk to, so we really get to understand that. Then vulnerabilities. Not only do we get to understand what we are vulnerable to in our environment, but we also get to understand who is checking for those vulnerabilities, right? Whether it's us or our threat actors. And finally, personal growth. We monitor our guest Wi-Fi. That is, I run into very few customers that happens. We do it on purpose. We monitor that environment through a captive portal where you submit an email address such that our level 1 analysts see bad things because it happens on your guest wireless all the time. And so this gives us something that we can actually get them working with and sort of train them up. So hunting has really helped us out in developing our talent on our internal team. Hunting is a journey, okay? It's not a destination. And so we take the hunting maturity model and we're going to walk through the stages. The whole point is, first and foremost, we need to get the visibility that matters. So we start with collecting data. Once we start collecting the data, then we can start doing things with it. Eventually, we talk about automating. Now, when we talk about automating in threat hunting, we are not of the opinion that you can automate the hunter out of the loop. The goal is to collect the information and provide it to an analyst in such a way that they can make the connections themselves. But like we said, the internet is a broken place. So we see a lot of things that look bad that will be just fine. Okay? So essentially our goal is to move up the hunting maturity model towards some level of automation. We start with that visibility. This is a lot, okay? It's all of your logs. It's full network capture, and then endpoint forensics data. And it's a ton of data. So big data is our lives now. I mean, it's just, we got to live with that. That's the way security has gone. Visualization is one of our big ones because of that huge data set, how do we pull it out in a way that we tie things together for an analyst to say, yes, this looks bad because of the other things I know about it, right? Essentially infusing threat intel, infusing endpoint data all into something that I can digest as an analyst very quickly. And then finally, automation. For us, this takes the form of reporting. We do large reports essentially to sort of risk order certain data for us, such that we can say, hey, look, start with these sessions and go from there. All of this, everything we're going to talk about, starts from that fundamental threat intel aspect where we're infusing that into the tool sets because, like I said, that's our fundamental aspect. So all of our alerts are actually threat intel hits, right? That's basic for us. So then reports on the output. Now, this includes your key performance indicators, right? The things your management cares about. They are also our results of our automation because we look through reports on a daily basis, not through the actual hunting concept every single time. We will walk through the hunting concept so you can see sort of how our mindset works, but there's a lot we've done to automate this so that we don't have to do it every single time. The hunting concept, essentially what we're doing is we're starting with that hypothesis that we're owned in some way, right? And then we say, okay, well, what does that look like? How would we find it with our tool sets? How would we uncover new tool sets based on the things we're seeing? And then how can we analyze that and do it faster again next time? Okay, cyber kill chain, right? Now, when we show this because the concept here is we need to figure out where we're going to focus our hunting efforts. Like we said, it's very, very difficult to hunt when you're not compromised, okay? So we start with everything after that. Now, it's difficult to hunt here, it's easy to hunt here, and this is just bad news, okay? So we don't want to get to here. But these are the 4 steps that we're going to look at: exploitation, entrenchment, C2, and exfil, okay? Now, when we take a look at these, we carve them based on the directionality of the traffic. If traffic is coming inbound, that's where I anticipate my exploits to come. That's where I anticipate entrenchment tools to be pulled down, to be installed into my environment. If I'm looking at outbound traffic, I'm looking for your command and control beacons, and I'm looking for your exfiltration, okay? Now, the next key concept for us is tunneling. You can tunnel over any port. So, if we were to go in and look at port numbers, we get stuck. Okay? So we go through and we call it service. It's protocol, however you define it, right? But the idea is separate port 53 from DNS. Yes, port 53 is DNS sometimes, but there's a lot of crap over port 53. And as analysts, if we were to take it port by port, we have to keep shifting gears in our minds every time we see one of those changes, and that sucks for us. So instead, we went, forget that, port independent protocol identification. It's not a very good acronym, but it's very good in concept. So this is our analysis. Then we go through 3 stages of each service analysis. We look at specific indicators first. These are your signature-based kind of concepts, okay? These are the easy things. The eval Z1, Z2 kind of statement characteristic of a China chopper web shell. That's what lives here. Then we look at technical aspects. This is HTTP posts where you didn't include a content length value. That's what tells us you didn't use the protocol right. Yes, it can still work, but you broke our technical aspect of our protocol. And then finally, behaviors. These are things like posts with no get. You're sending data to a web server without ever getting anything from it. Users don't do that. Machines do that. And so that's what we try to separate out with the behaviors. Now, our maturity, this is where our level 1 guys look, and then we try to push people up to start being able to pull out more and more from the behavioral aspect, because that's also where our utility goes up, right? I don't have to do much to change this as an attacker, maybe a little bit. That's going to be hard. Mimicking a real user in your environment is going to be difficult for us. So now we get to the labyrinth. Once again, we named it this because it's a mess, all right? So it's gonna look ugly. We start with direction, inbound or outbound, okay? Let's start with inbound for our process of walking through this. Then we're going to pivot on service, protocol, whatever it is, right? Just not port number. And then from here on in, it's just protocol analysis, right? We pick our favorites and we walk through things that matter in each one. In HTTP, we look for methods, okay? So this is your get, put, post, head options, so on and so forth. We look for strange sequences, post, no gets. Only applicable in HTTP 1.1 and on. That's the first time we introduced the concept of pipelining, where you could put more than one in a single TCP session. So if you don't have, so when you look at it from a session perspective and you get more than one, that's the first time you can do this. Otherwise, it's very difficult for us to know. Inside the URI, this is your Universal Resource Identifier. It consists of the resource you're trying to access on the web server. When we look at URIs, we look for encoded query strings. Now, the reason we look for encoded query strings is because cat etc password stands out very obviously to analysts. So as an attacker, I'm going to encode that in some way, and a query string provides me a way to submit data in like a HTTP GET request. One of the default Kali Linux web shells uses this technique, right? An encoded query string where the command's in there. So that's the kind of thing we're looking for. Also, short file names, a.aspx. Now we use short file names because they're obscure, right? And so the only person who would ever use an obscure file name is an attacker. But that's not true. We also taught our developers to use short file names for the same reason, to keep their websites from being reverse engineered. So these kind of things start to stand out to us. Now, we should mention at this point, these are not alerts, right? If you were to put this into an IDS alert, you would live here because it happens all the time. And you will never do anything else in your career. So the reason we put them up like this is these are the, I liken it to like a feature set. These are the features of the things we're looking for. And any one of them can be the thread we start pulling on to find the rest of the weirdness, right? But I will show you the one alertable section in this presentation. Other than that, none of these make good alerts, and that's why it's hunting. Headers, okay. Headers are name value pair, colon separated, return new line for each new one in the header, or in the HTTP session. When we're looking at headers, the first thing we care about is just the number of headers. If you have 6 or more, you start to look like a user, because you have a host header, you have a content length and accept language, a content encoding, user agent, right? I mean, we can count them up pretty quick. Machines don't need those, they will use less. And that's where we start paying attention. So the very first thing we're going to look at is just your number of headers. Then we take a look at the host header. This is the server you're trying to interact with. Okay, so this is one of the places where you could look for like domain fronting, right? This thing doesn't line up with where they're trying to go. That's the concept in domain fronting, essentially a separation of the OSI request from the underlying request such that they can still get through your proxies and things. So host header. When we look at host header, we look for direct to IP addresses. Keeping in mind that machines are 32-bit values for an IP address. It doesn't matter if it's dot decimal, it doesn't matter if it's octal, it doesn't matter if it's rectal, it doesn't matter if it's doesn't matter if it's hex, it doesn't matter, okay? So they don't care as long as they can get it into 32 bits, which means that we have to keep in mind anything that's not dot decimal but can still be interpreted as 32 bits shows up here. Okay, user agent string. Now, when we look at user agent string, this is the point of the user agent string is to tell the web server, this is the environment I am browsing in, please format it appropriately for me. We want to look for old ones. This is what happens when your script kiddie recompiles the Zeus binary. And they don't change that field, we get an old user agent string. Okay, so we'll look for old user agent strings, i.e. 3. Right? Nobody uses that anymore. I should never see it in an environment, except that it happens all the time, because somebody has some system they can't update. Known bad ones. This is Mozilla, where you replace the O with a 0. That's just wrong. And there's your first alert, and only one in the presentation. Okay? That's the only place I can actually alert, is to look for known bad user agent strings. After that, we go to short ones. Mozilla 5, completely valid, but actually too short to be meaningful for formatting my response to you. What WebKits do you have installed? What operating system are you running on? You didn't provide me enough information. You provided a valid answer, but not enough information. We look for refers, okay? A refer gets appended when you go to a website and they refer you to another one. For example, you go to a search engine like Google, and you want to find a washing machine, you type in washing machine, and then you click on Amazon or Sears or Walmart, I don't know, whatever link it is that you care to go shopping for. Well, Google will append a refer because they want to get paid, right? This is how they say, they came from here, please spend more advertising dollars with us. When we look at refer, we are going to look for ones that are missing. This is a behavioral aspect to be combined with things like strange sequences of methods. A post no get with no refer tells me you didn't go to a search engine and you came straight to the website and just sent data. People don't do that. We also look for strange ones. Now, keep in mind, this is incoming traffic to your public-facing web servers, possibly, which means if you're a big organization, you can expect to see this from everywhere. So potentially, you could see search engines like Baidu, which is very popular in China, but nobody uses Bing. So look for that one, right? Accept language. This one is very contextually sensitive. Essentially, the accept language tells me as the web server what languages you speak. You speak English preferably, but you also speak French. Okay, I'll format my response appropriately for you, trying to accommodate your language preferences. If you happen to know that nobody should be coming to your site from Iran, and you see the Persian language code, first of all, you didn't get their A team, because they can do better. But you might be able to use this to catch some of their lower level operatives. Content length. So we talked about this one just high level real quick. Essentially, the idea is to make sure that it's there. If it's missing, you broke the protocol. But I wrote the web shell, or whatever it is I'm trying to access in your environment, and if I wrote it, I don't need that field. More accurately, I can have one and it's just wrong. Like, it doesn't have to actually be right. So I can just keep moving with it, right? And so that is the kind of thing we'll look for, is those kind of mismatches. Yes, something is there, but you're not using it correctly. Then finally, body, we look for specific indicators, evals, E1, characteristic things of China Chopper, or other ones that we can easily identify. SSL TLS, it's encrypted, give up, go home. Well, that's not entirely accurate, okay? First and foremost, we can pull out the cipher suites. So the protocol and the cipher suite that you're using, when we pull that out, it gives us the capability to say something in our environment is still supporting TLS 1. We should go find out who that is, right? This is a great way to make friends with your operations buddies, is to say, your crap is broken, and I can see it. Also, SSL-CA and subject, what we're looking for is self-signed certificates. We typically should not see this anywhere in our own environment, except for your developers. You can count on somebody having done it. So another place to go make friends. Inbound DNS is always bad. No, how else would anybody find you on the internet? DNS traffic, what we care about is recursive DNS on inbound. Essentially, if I go to rsa.com and I say, hey, can you look up cnn.com? And we say, sure, I gotcha. That's a bad sign, because we should not resolve domains for which we are not authoritative. This is not that we are owned or that you are owned. That's not the issue. The issue is all I have to do is spoof a source IP somewhere and now request that you resolve the .coms and send it to unsuspecting victim 1. Now they get all of the internet dumped on them for no good reason, right? So we just don't want to be part of somebody else's bad day. SSH, RDP, also encrypted, so there's nothing you can do. It follows the exact same concept with the certificate exchange and handshake up front, which means that we do get some plain text information and we will use that. Now, the first thing is it's always bad to see inbound SSH and RDP. This shouldn't happen. We should be blocking this at the firewall. So we will start here and see if we can, if we have anything broken, right? Now, inevitably, we find this more often than you would think. The next thing we do is we look at client and server versions. The reason we look at client and server versions is because a legitimate example of inbound SSH traffic is for secure file transfer. If you host a secure file transfer server and somebody connects in over SSH, now I have, or connects in to pull a file, now I have an SSH session inbound. So look at the client server information. We can tell whether it's a file transfer server, whether they're connecting using PuTTY, or any other of the clients that people like to use. So we'll look for that. And we'll find something. Then what do? The next thing we want to look for is a session size. Now, I say session size. In reality, what I mean is a combination of a few different aspects. One, the total bytes of sessions sent. If it's large, I start thinking file transfer. Then I want to look at the sent-received ratio. If it's an inbound session, but most of the data is being downloaded, i.e. is outbound, then we want to look for, then I start thinking file download again. I also look for a session lifetime value, essentially how long has it been open. Because a long, small session with a medium ratio, about the same amount of data sent and received, looks to me like an interactive SSH session. And that's the one I'm actually concerned about. So that's what we'll look for. All right, that's all the inbound ones. Outbound. Okay, we're going to do the same thing, pivot on service, and we're going to start walking through each protocol. Now, HTTP, we're going to do the same things, but this time we're looking for command and control or data exfiltration. So we start with methods, strange sequences, headers, user agent, old, short, bad, host header, direct to IP. Now we'll have our first new thing that we care about, okay? Keeping in mind that most often here we're thinking beginning. Strange host headers, okay? When I say strange, what I mean is domain generation algorithms, right? The concept is essentially, I know you will eventually blacklist my IP somewhere. You'll probably also blacklist the domain. If I can pseudo-randomly sync the one in my malware and my C2 server, and I just pivot them continually, now you can't keep up, which means that they ought to look seemingly random. And so that's what we're going to look for. We tend to do this based on host names with consecutive consonants, okay? Because people don't use English language that way. Now, so we set the limit at 3, and it turned out that that was just massively unfair to Polish websites. So we changed it to 4, and so now we use 4 hostname consecutive consonants. Also looking for dynamic DNS, it's like one step down, right? So instead of rolling my domains, I can keep one domain, I can roll IPs, okay? So we'll look for that one. Referrers, okay, same, just missing, content length, missing and wrong. This one specifically right here is your MSU rat, okay? This is they set this value to 4096, even though they don't send nearly that amount of data. So that right there was the MSU rat. Body, specific indicators. Now, on this side, it's worth noting that specific indicators for us is things like GET requests for small Java jar files, because that is a favorite technique of exploit kits. But an exploit should live on this side, right? Because we said earlier, exploits are inbound. And that is correct. The data will still be inbound. It's a GET request for it. But because it starts with the GET request, it looks outbound, right? And so we have to take into account which way the data is moving, and the jar file is inbound into our environment, even though the whole session started as outbound. So that's what so we'll look for those kind of things right here. 0 by 0 iframes, 1 by 1, iframes with a PDF, JavaScript, all this kind of stuff. We'll look for specific indicators here, typically associated with exploit kits. SSL TLS on the outbound side. We get the same information, we will use it the same way. Subject and CA, now I will say, on subject and CA, because we can see that, if you were to generate an SSL certificate, and at all of those default prompts, let's say default country, default city, default organization, you just hit enter, we see default country, default city, and default organization in Russia. And we know that's not right. So we'll look for those kind of things. Strangeness in your certificate change. Also, the self-signed ones, this has, there are some services out there that make it very easy for you to encrypt your traffic. We would also keep an eye on them. And then interval. Okay, when we talk about interval, if you were to send one beacon every minute for 24 hours, you would end up with 1,440 sessions in a day. So 1,439, I'm going to let it slide, right? There's some wiggle room there, obviously, and we look for factors, multiples of that number. But the concept is, if you are using this as your botnet C2, this can be an indicator. It is an indicator of C2 servers everywhere. We put it in SSL because we get so little other data to play with. Okay, so that's why it's under this one, but it does apply to any other C2. DNS traffic. Okay. First and foremost, we're going to look again for those dynamic DNS domains. Oftentimes, we find your Plex servers. We know. Then we're going to send you a friend request. Tunneling. When we look for tunneling, what we're talking about in this context is essentially you are authoritative for badguys.com. You own it. So you can encode data into any subdomain that you want for badguys.com. So that's what we're going to look for. But this technique is so old that nobody uses it anymore, so don't pay any attention. Except that the Project Sauron Strider malware used this exact technique for their exfil, except that they did a unique trick where they limited the number of characters in the subdomains to no more than 30. It just takes them longer to exfil, but it's much quieter now. And that can get around a number of techniques, but it won't get around this one. We look for a large number of subdomains for each root domain. So badguys.com suddenly has 300 subdomains in our environment. Google has, in an enterprise environment, on the order of like 80, 88, maybe 100. So you have 3 times more subdomains than Google. Not likely, right? So we look for a large number of subdomains when they're doing their exfil or their command and control. If the C2 server is just getting check-in messages, we expect to see a large number of one subdomain, right? The hello message over and over and over on the order of 1,440 times in a day, right? So we'll look for that. Also, lots of null and text records, large text records works. Now, because essentially, like in a text record, right, you can get a response back, so it makes it great for command and control, because that gives me a mechanism to get data back in to talk to my malware. Now, so we'll look for lots of null and text records. And if you see this DNS tunneling, it is always malicious, except that it happens all the time. Your AVs, McAfee, will use this kind of technique to do lookups, reputation lookups on things. So we see it all the time. So you can alert. File transfer over DNS. That should be an easy one. File transfer is, think of it as analogous to service or a protocol. It's not based on an extension, it's based on file header structures. Okay, so by scanning through those, if you find a file header structure, you're like, oh yeah, definitely. Except your zone transfers will trip over this rule, right? So you can't look, so can't alert again. SSH and RDP, but this is outbound, so it's totally fine. That is also bad, okay? This is our reverse tunnel, okay? Chances are you won't let me do this. I can't SSH into your environment, so I'll put the malware in and I'll make him call me. Fine. Also bad, except it happens all the time. Now, one of the reasons it happens all the time is for our same scenario, right? Somebody's reaching out to a secure file transfer, or you went to a vendor and they sold you some hardware, and they went, and we will manage it for you. Don't even worry, it's going to be great. Oftentimes they open up a reverse tunnel into their environment for just that purpose. So we see it. Essentially, client server information will tell us whether it's an FTP. Then we start looking at session size again to see if they're active, right? This is the kind of thing we would turn into a report that essentially we run and look at the ones we know should be there and check out the ones that are bad. ICMP, okay. There's something very unique about ICMP on this list. It's the first time it's a network protocol as opposed to a layer 7 protocol, okay? Which means that if we look for layer 7 protocol header structures, we might find them being just tunneled right over ICMP. So if you run SSH right over ICMP, boom, gotcha, right? It also means we can look for file transfers over ICMP. And if I see a file transfer or another protocol over ICMP, that will always be malicious, except that it happens all the time. It happens all the time because ICMP originated as an error reporting protocol. And I would send a packet, and it would respond back and say, I'm sorry, destination unreachable, I could not deliver that packet. And I said, which one? I sent you 1,000. So to get around that, they decided that they would send at least the first 64 bytes of header information back. At least. They can send more, and if the amount that they send you contains the header structure of another protocol, you can get a false positive here. You can also get a false positive if the originating packet had a file in it, right? So that's what we're concerned about here, is looking for these, but now we got to eliminate our error messages, right? When we eliminate our error messages, we're left looking for large ICMP echo request and echo reply. This is the ping message, okay? Now, back in the days of collision detection multiple access, when we were just a bus and we had to negotiate collisions and all this kind of stuff, we had to worry about padding to make sure that somebody talked long enough on the wire that everybody could recognize that they were speaking. So we look for large as a very, very small number of bytes. You can set it like 70, right? And that will always be malware, except that it happens all the time. The reason it happens all the time is because there are cute admins. We know this because they've replaced the traceroute application with a 99 bottles of beer on the wall counter. All of that padding now trips over these kind of concepts, right? And so you can't just set it and be done because of these cute admins, just when we had something we could alert on. What we actually look for is a difference in the request and the reply padding. The idea here is, if I ping out, I'm the malware, and I ping out to the command and control server, he has no way to ping me back. So he must send his data in something that I've sent him that will get through our defenses, right? So he'll send it in the padding. I send him one in the request padding. There is no reason for you to ever change that padding. And so this will always be malware, except that it happens all the time. SolarWinds uses this as their status check-in. I just can't win. So that's ICMP, okay? We look for these. You just got to eliminate the ones you happen to know are SolarWinds. File transfer protocol. In the world of data exfiltration, this is a fantastic technique because it's very easy for me as an attacker. It also requires me to spend very little time setting it up, and then I can send my data. And if this is the last thing I do as an attacker, I would often come in, zip stuff up into one spot, exfil it on my way out, and I'm done. Which means I can put my attacker handle here in my username and password, and ponage as the password, or you've been effed, right? And so we see a lot of profanity in username password combinations. So this gives it away more than you would think. So we will look here. It also means you didn't get the A team, right? They're not planning on coming back if they're exfilling with that kind of stuff. Command and control. One of the less known uses for FTP is a command and control server because we have store and return commands. I'm either putting something onto a server or I'm pulling something off. Very similar to a get and post. And we'll use it similarly, okay? So I expect to see a lot of back and forth on the store and return commands. I mean, a lot for very small files. So we'll look for that kind of thing if the command and control channel is active. If it's not active, we look for a TCP SYN beacon. Now, this is essentially if it's been taken down and we're still infected with the malware, but the C2 is no longer up, or it's been quarantined, or whatever. Now, this, once again, is one of those things that applies to any C2 server, anywhere in any of these protocols. It fits here nicely because we look for it on port 21, right? That's where we're going to look for it here. Now, because we can get that port information. It applies everywhere. Essentially, our way of handling it is bounce it off your threat intel. If it looks like that IP has been hit or is known to have a C2, you can find that out. If not, we literally just mark them on a list and look to see if we've ever seen it before connect, or if we see it again in the future connect. Because it's very difficult to figure out what's going on in a SYN beacon. Like, I don't know if that's malicious or not, right? So, finally, in our mutually exclusive, collectively exhaustive process, where our goal is to take swaths of traffic and add them up until we have a whole, we have the everything else bucket, okay, called other. In the everything else bucket, our main concern is to look for custom TCP shells, okay? So when we're looking for, like, let's take Poison Ivy. If Poison Ivy is doing their random encryption with Camellia, and they've got that 256-byte handshake, that doesn't tell me much information, okay? If I see it here, it gives me the idea that it could be true. You know where else I see 256 bytes of random information show up a lot? Right here. But if it's here, it's not Poison Ivy, okay? So hence the point of breaking things down this way. What we actually want to care about here in service equals other is, first of all, the byte sent received ratio. Are we pulling data down, or sending data out, or is it medium? That's the one that makes me start thinking interactive sessions, okay? TCP shells. We also look for entropy ratios, okay? So entropy, measure randomness and information. If you see, let's just use it on a scale of 0 to 1, let's say. So 1 is completely random. So if you see like 0.997, you will go into that session and be like, who is this? This is very, very, very obscure. Chances are it's encrypted, and it's probably Facebook Messenger, okay? It might not be. It might be like Google or somebody, so you might get a little more information out of it, but the ratio is the important thing. Fully encrypted means somebody spent a lot of work making sure you couldn't get into that. And we are not that, we don't do that much work, okay? So as an attacker, probably not gonna go to that level. Now, if it's plain text, you're looking at about like 0.23, 0.29, somewhere in that range. So the sweet spot for looking for our custom TCP shells is that range in the middle, right? So like 0.5, 0.4 and up, but not all the way encrypted. That's when they've compressed it. They've used RC4, 3DES, base64 encoded it, or just simply XORed it, okay? It makes it look more random, and it shows up in that sweet spot in between those two extremes. So that's what we'll look for there, okay? All right, and that is the labyrinth. That's it, it's done, okay? And now you can see why we called it that, because it is a mess. But it's the process we walk through when we go into customer environments, when we walk through our environment, is the methodology we use in our brains to look for things and to avoid that cognitive bias that we all have as analysts. All right, and that's it. So, any questions? Catch me afterwards, because I think we're out of time. Do we have time? Okay, cool.
The question is this automated, or are you doing this manually, packet by packet? And are you using Wireshark as or derivative of that for this, or how are you going for this?
So RSA has the NetWitness suite. So that's what we tend to use for tool sets. In terms of automated, the goal is with whatever tool Wireshark, I mean, Wireshark's not going to really do it for you, but whatever tool you have to do like Bro, like if you're going to use something like that, just make sure this is available to you as an analyst. That's all we have it. In an IR kind of scenario, when we go in, we come in and we go session by session through each one, looking at them. Not through each one, through the ones that stand out in some aspect, and then we pull on that thread until we find it's either fine or bad. In an operational environment, a lot of this is automated for us. We start with essentially a report of all outbound SSH sessions, and then we go, and these are the ones we know are from Intel hardware. These are the ones we happen to know are EMC hardware. And so we eliminate those ones, and then what we have left, we go, okay, do any of those look weird based on any of these aspects?
You get frustrated doing it?
There is a lot of both. So the question was, do we get frustrated doing this? And the answer is yes. It definitely does happen. Because oftentimes you will go in and you will go through hundreds, thousands of these things, just looking through. And most of them are Android apps, ad traffic. There's a lot of things that are just fine that the programmers just aren't diligent enough to follow the RFCs, to do it correctly. And so we come across a lot of things that are just broken. However, it is very exciting when you find something, so that's why we keep coming back. But yeah, there's definitely some masochistic tendencies in all of the hunting analysts, I think.
All right, well, thanks so much, Matt.
Thank
Appreciate
you.
that, and this closes out our last session of BSides Calgary. If I can ask